Hey, let's get right to it and add some notes to our homework that we were doing yesterday and the day before in Desmo's classroom, right? So when I look at some of those problems that we saw in Desmo's classroom, the equations were solved for a particular variable. Either both of them were, like this one solved for y, or one of the equations was solved for a variable. Hopefully you can see what I'm pointing at right there. Let's see, I'll highlight this. See, this equation was solved for x. The x is all by itself, which makes it really easy to take 2y minus 3 and substitute in for that x right there. And that's what we have in our notes already. So I'm not going to take a ton of time kind of reviewing that. I'm just telling you, in your notes, you should see something like this. We circled this and we drew a little arrow right to the x, and we said, okay, 3 times 2y minus 3 minus 7y equals negative 14. And then we distributed, we're practicing keeping track of detail like that. Make sure you distribute the 3 all the way through. We're trying to improve our skills and kind of clean up some of the errors that we tend to make. The more practice, the fewer errors we're going to make. And then we're going to add like terms here. So we get negative 1y minus 9 equals negative 14. Now watch me make a mistake right here. Plus 9 on both sides, right? And I'm going to look over at the sideboard here in just a second and see if I've got everything the same as we had on our wall over there. Yes, mine's looking exactly the same right here as it does over there on the whiteboard. And then I divide by negative 1 and I get y equals 5, right? So this is called the substitution method. You take that 5 and you plug it back into one of the equations. Doesn't matter which one, but I'm going to plug it into the second one because it's already solved for x. So I get 2 times 5 minus 3. I get 10 minus 3 is 7. And so that means the two lines intersect at 7 comma 5. Make sure you put them in the right place here. X is the 7, the y is the 5, right? Man, I hope I'm making this clear. I hope this sounds easy to you and that you're able to focus and not get bored by it, that you're challenged enough by it. Well, look at these situations down here. Neither one of the equations are solved for a particular variable. And you might say, man, I really like this substitution method. I'm getting kind of good at it. I think I could solve one of these two equations, not without, too much work. For a particular variable. And you're probably right. Like we could move the 3x the other side. We could divide by negative 2. But you quickly get some fractions. And there is another way that is really not that difficult to deal with. The other way is called the elimination method. Now, I copied both 9 and 10 in your homework because 10 is set up a little bit better for the elimination method. And the reason why is because, do you see the coefficients for the y variable? The coefficients are the numbers that are in front of the y. So this one's a positive 2 and this one's a negative 2. If I was to just add the two equations together right now, let's say I drew a little line under here and I put a little plus sign out front. What's going to happen to the y values in this situation right here? Well, if I add these two guys together, they're going to go to 0 y's. And a lot of times people don't write anything down here because 0 times anything is 0. So these two go to 0. I might put a 0 here for our notes, but in the future, I'd suggest you don't even put anything down. And then we get negative 1x. So I got negative. I'm not going to put a 1 in front of there because that's what that means, right? Like when you have an x here, that means 1x. If I wanted more than 1x, I'd put a number in front, like a 5 or something, right? Okay, then I add these two numbers together and I get negative 2. So like on 2 steps, I've got my x value is 2, right? And we're going to, of course, plug that 2 back into either that equation or that equation right there. But, let's just stop for a second and say, well, why in the heck does this even work, right? Well, what are we saying this top equation is equal to? It's equal to 12, right? So really the left side over here is really 12. It just doesn't look like it. 5x plus 2y is definitely 12, right? And the right side over here is negative 14. Well, the left side doesn't look like negative 14, right? It doesn't look like that, but that's really what it is, okay? So let's put negative 14 on the left side, right? The right side's negative 14. The left side's got to be negative 14 also. What would happen if I added these two sides, the right side and the left side here? If I add those two together, I'd get negative 2 equals negative 2. That's an equation, right? That's still true. This is a true statement. Like this was a true statement. This was a true statement right here, right? All right. Hey, let's just stop for one moment here and kind of gather ourselves. What in the heck are we really doing? Well, we're really doing problems in the future that, like even this word problem where we had that car rental problem, these are real world applications, but they have to be kind of brought down to a beginner level. So you might say, well, I'm not going to work for a car rental company, or the car rental company would be way more complex than what they're setting up here. You might be right. You probably are right that these equations would be way more complex, but it's still a system that business people would have to solve, and they need some algebra skills. And that's what we're practicing right now, just to make sure that we don't make mistakes with our algebra. Okay. So that was easy when the coefficients are the same. But what if the coefficients are not the same? Like here's a 3, here's a 5, here's a -2, here's a 3. If we add the two equations together right now, neither one of the x or the y are going to go to 0 y's or 0 x's. So here's what we do in that case. We're going to look for a number that we could multiply the top equation by. What could we multiply the top equation by? And then a different number that we could multiply the bottom equation by. And when we multiply by those numbers, we're going to get new equations that are equivalent to the original equations, but the coefficients either in the x or the y would be the same number. And it would be ideal if they were the opposite in sign, like 2 here and a -2 there. That was beautiful because it gave us 0 y's, right? So I think I would opt for the y variables because they're already different signs. If both of these were positive, both of these were positive, then I might multiply one equation by a negative and the other equation by a positive to create that difference in sign. Or you could subtract the two equations, which is a more kind of sophisticated way of thinking about it. So let's say I multiply the top equation by 3, and I'm going to multiply the bottom equation by 2. Okay. So what's going to happen, since I already have the blue pen turned on, I'll multiply the bottom equation by 2. I'm going to get 10x. I'm going to get 6y. And I'm going to get -50, right? I'm just multiplying everything here by 2. I'm distributing a 2 through right there. Okay. So maybe I'll make another little note right up here. If I multiply that by 2, okay, then I'm going to multiply the top equation by 3, I said, right? So I'm going to multiply the top equation by 3. So I'm distributing a 3 through, and I end up with 9x minus 6y, right? Because 3 times -2 is -6, and 3 times 4 is 12. Okay, so now we have two equations that have the same number but opposite in sign, which is beautiful because now I can just use addition. And when I add 9 and 10 together, I get 19x. I get no y's. This is where I would just suggest you put an equal sign down because the y's went to 0. And over here, I've got -38, right? Because 12 minus 50 is -38. Now, if I divide both sides by 19, I'm going to make that on a new line here, just so in case somebody looks back at my notes, like I'm going to divide both sides by 19, and I end up with x equals -2. Okay. So then I take my -2 and I plug it back into one of the top two equations because they have smaller coefficients. I wouldn't substitute it back into these equations because they were multiplied by 2, so they're just twice as big as we need. Not that it's going to give us a wrong answer, it's just harder arithmetic to deal with. So I'm going to plug it into the top equation because it looks like it has the smallest numbers. So here we go. So I'm going to plug that in. I get 3 times -2 minus 2y equals 4. I get -6 minus 2y equals 4. I end up with, let's see, when I add 6 to both sides, right? Add 6. I end up with 10 on the right side, and I got -2y on the left, and then I divide by -2 on both sides, and I end up with -5. So right here, I divided both sides by -2. Maybe I'll put that out here. Divide by -2 on both sides. All right, so I've got my ordered pair, -2, -5. If I was to plot this, I know I'm running out of time here. I've taken a lot of your time up. I really appreciate you paying attention and taking some notes right now. I would go over to Desmos, plot both those guys, and see if it really does intersect at -2, -5. If it doesn't, then we go back and we look and see, did we make a little arithmetic mistake somewhere? You could also take the -2 and the -5 and plug it into the equations to check your work, right? Now, I know that takes a little bit of extra time, but it's definitely doable, right? Negative 2 times 3 minus 2 times negative 5. Does that equal 4? So I get negative 6 here, and I get a positive 10. I get a positive 10 over here. That definitely is 4, right? So it looks like negative 2, 5 works on the first equation. Let's see if negative 2, 5 works on the other equation. So I go 5 times negative 2 plus 3 times negative 5. Does that equal negative 25? I got negative 10 minus 15. Yes, it does. That is definitely negative 25, right? So I've checked my work, just by substituting in, but I could also check my work on Desmos by graphing the lines and seeing if they intersect in the right place. Thanks for watching my video today. I hope I'm making this clear. I need you to finish the homework, and the homework is on page 539. We're doing 9 through 14. I just kind of set up 9 and 10 for you. I almost did all of 10 for you. I did all of 9 for you. Please copy that into your notes. If there's any questions, you just raise your hand. I'm going to run right over to you and help you out. Okay? I want you to get this homework done. Thanks. Bye.